Alright, in this video we're going to build off of our just one basic attack and add in a combo attack system. Included in this will be a way to reset back to the just first attack if we don't click within a certain amount of time. And this is also a dynamic solution to allow for any length of combo attacks for whatever your animation, your sprite sheet may include. So this one is 3. As we can see here within the character, he just has a first, second, and a third attack. And you could go anywhere from 1 attack to as many as you'd like, 9, 10, 11, however many attacks you end up wanting. First, we're going to cover actually about the max amount of attacks. So in a previous video, I created a player character base. It is a parent blueprint to all of my characters. It allows for a quick way to make new characters without having to copy paste all of their information over, all of the basic settings. If you haven't already watched that video, I would recommend going and seeing it, as it's a very clean solution and quick solution to creating new characters. So if we open it up, or if you don't want to use this, just open up your character, and we're going to add a variable called max combo attacks. And when we then come in and create a child blueprint, or open up our our child blueprint or our just character, if you're not going to use the parent child solution, if we open that up, we can then see that this child has inherited the max combo attacks variable, and I set it to 3. As I just mentioned, there are only 3 attacks within this, I keep forgetting the word, within this sprite sheet, so I will set it to 3. Next up, we need to open our main player controller and add in 2 variables, one being combo queued, a boolean, and combo index, an integer. I've put these under a category just called combo. Keep things nice and clean. And now we will add in the actual attacks themselves within our character's animation blueprints. I have a jump named ground attacks. This will differ from aerial attacks, which is something I will add in the future. The ground attacks will go, the jump will go to the first attack, which will then be connected to our second attack, connected to the third attack. Each of these will connect back to the idle, and their transitional rule will just be the basic when the time remaining on the animation is equal to 0 for each of these 3 will be the same, just time remaining equal to 0. And this will differ from the transitional rules between the attacks themselves. The first difference is how we've added in a priority. Probably 2 or 3 videos ago, I went over transitional priorities, and this is a way to have multiple transitional rules without them overlapping or getting bugged out. So the highest priority will be checked first. This is a priority of 1. This is a priority of 0. Each of these are 0 priority. Both of these are priority 1. They will get checked before checking these. Within this transitional rule, we'll see that we still check for the time remaining to be equal to 0, while also checking our pulling from our main player controller reference, checking the combo index equal to 2. And this is from the first attack to the second. So that is why we're checking if it's equal to 2. And then from attack 2 to 3, we check if the combo index is equal to 3, while still having that time remaining equal to 0. Perfect. All right, we can hop back into the main player controller where we're going to implement the actual logic behind the combo. First thing we need to do is go to our attack input action. We need to do a check from our player character movement if the character is moving on the ground. If this is false, we're not going to worry about it for now. That goes into aerial attacks. If it's true, we will then perform a switch on our player states. If you don't know what the player states are, if this is your first video, once again, I would recommend starting earlier in the series. I go over this. This is going to allow us to swap between a few things going on within our character. So to start out, on our first attack, the player state will be equal to none. So then we can set it to be equal to attacking, perform a jump to our ground attacks, and then we're going to do what I call an idle fix. This is the idle fix graph. Now, in the last video, I covered a problem I found within the mantle where this jump doesn't actually jump to the animation fast enough. It doesn't get to the flip book and the animation. There's some amount of delay probably within the code. And there's just enough of a delay. It may be 1 or 2 frames, but this will cause things to break where we are continuing our logic, our blueprint logic, while this is not to the correct animation yet. And it literally could just be a few frames, but this will cause problems. For the mantle, it was not checking the correct flipbook because this hadn't truly swapped over to the correct flipbook. And so over in the attack, we're going to perform what I just called the idle fix. If I open up the collapsed graph, just to mention, a collapsed graph is made by selecting any amount of code, right-clicking on it, and collapsing the nodes. So we'll open it up and we'll see that all I've done is pull from our animation instance, gotten the player, and then searched up bind event on changed. So we want to bind event to on playback sequence changed. So this will bind this event, the idle fix, whenever we change our animation sequence. So we know that there is a small amount of time in which an idle is being played, and we want to stop all future logic from happening. We don't want to do any combo logic until that is gone, until it is swapped from idle to our first attack. And this will do that. And immediately we're going to unbind on playback sequence changed. Once we've gone from the idle or whatever starting animation over to the first attack, we no longer want to call this. If we don't have this unbind, it will then cause a error in which anytime we change any animation, it will call this custom event. So we immediately unbind it and we continue down our logic pathway. First thing we need to do is increment our combo index, and then we will come to another collapsed graph, which contains a bit of a combo timer. And this combo timer is going to be similar to the last event bind we just did, except this is on playback sequence complete. And once the animation is complete, it will run this custom event, which I've named combo check, which immediately unbinds and then continues down the logic pathway. So why this is a timer? It doesn't include any necessarily timing windows that we've stated. It's not like waiting a set amount of time. We could implement that in the future. For now, I just have it set to be the length of the animation. So once this animation has finished, we will run the event, and this event will then continue checking down this. So we have a timing window during the actual animation wherein we can queue the next attack. And we'll see that right here, where once the event has started, so once the animation has finished, the first attack we'll call it, once that's finished, we're going to then immediately check the combo queue. And we want to know if another combo has been queued or if it has not been queued. This will allow us to then in turn continue down our combo animation line or just reset. So we need to actually affect this combo queue. We haven't done that yet. And how we're going to do that is over here off of the switch from our player's movement states. And what we're going to do is when the player states is equal to attacking, if we then click again, so we've clicked the first time and it's set it to attacking. Now if we click again, it will be equal to attacking. and we're going to do a branch check on our combo queued. As long as it is equal to false, we can then set it to be true and increment the combo up once. What this little bit of branch does is stops us from spam clicking and that incrementing up our combo more than it should. So it will just allow one click through until this is then in the future set back to be equal to false. So now that it's set to true, we can no longer increment our combo up. But we have it set to true, and that was what mattered right here, where we now know that we've clicked again within the timing window. Because of that little bit of time that we had while the animation was playing, we were able to set this equal to true and continue through here. If we hadn't clicked again, the combo queue would have been false. It would have gone down here and it would have reset the combo by setting the player state equal to none, combo to 0, and the combo queued to false. But because we've clicked again, it will be true. And the first thing we're going to do is check if our current index is less than the max amount of attacks within the combo. If that's true, perfect. We need to now set our queue back to false and then loop our combo timer, combo logic again. And we will continue doing this until we have reached the max amount of attacks. So when the combo index is now equal to the max combo attacks, it is no longer less than it. So it will be false. And we will do a final little bit of logic and reset everything. Within this final graph, we just have, once again, another bind. We have to do these binds because they are a guaranteed way to stop and start our logic. We're not relying on any amount of frames. We're not relying on any variable like float. It is a set. The animation is now complete, so we can continue. And this is identical to the combo timer. It's just a on playback sequence completed, and then we will have, I just called it final combo. And the reason we do that right here is because we still need to wait until the animation itself finishes. We want to make sure that final animation has finished before we do anything else. We need to make sure that we're not trying to then move or maybe do some other type of attack, like a bow attack or something. We need to make sure this is finished, and then we'll do that same reset. All right, perfect. This has been a little confusing with those binds. We are using binds to stop and start our logic to make sure that everything is in order. This combo timer will probably be the most confusing part of this entire video. I call it a timer. It's not necessarily a timer. We'll just, here, let's get rid of that. We're not going to call it a timer. We're going to call it combo window. So we have this window in which we can click again. So we've come in here, we've bound this custom event to continue down our logic pathway once our animation is complete. So in the meantime, while it's waiting for this animation to be complete, we have that window of opportunity to then click again and increment our combo index up while setting the variable to be true, which will then allow us to continue down the looping pathway. And this is why it is a dynamic solution, because you can have your max amount of combos be however many you need, and this will continue down until you reach the max or until you have no longer queued another attack. I hope that makes sense. Please feel free to ask as many questions as you'd like. Once again, I made a Discord. Woohoo. 2 people have joined it. It's excellent news. I'm in there to answer any questions. If it's simple enough, even semi-complicated things, I can either type out a solution or record a quick video for you and try to help you on your pathway of coding whatever you'd like. So yeah, this is a pretty dynamic combo system, and I hope you like it. I hope it functions well for you. Let me know how it goes. Thanks for watching.